I am Parikshit and welcome to another very exciting session on Unacademy CAT-alyst. In today's session, we are going to discuss some of the most important questions on the topic probability. Remember, this is one topic which scares a lot of CAT aspirants, but if done in the correct way, this is one of the easier chapters in Quants. So let's get started with some exciting questions on probability. Okay, this is me, your educator on the platform with the highest live class rating on Unacademy thanks to my learners. Yes, a lot of happenings on Unacademy in the next few days. A complete weekend batch starts on the 22nd. Then on the 22nd, we also have a new batch. In fact, the first batch for CAT 2022. And also we have a percentiler batch starting on the 26th of May. Now, if you are interested to join any of these batches, remember, you got to subscribe either to Unacademy Plus or to Unacademy Iconic Subscription. And when you do so, if you need some exciting discounts and maximum discounts, use the code which is there on your screen, Parikshit Live. If you use that code, you get 10% discount on the subscription fee, and also you get free mentorship from my side. And mentorship is all about going beyond your class hours to help you with any doubts, any queries, help you prepare your strategies, and a lot more. Tell your CAT. Let's get started with today's session. Okay, let's get started with today's session. Yes. So we have some questions on the screen, right? And let's pick them up one by one, right? Let's focus on the first one. A and B are playing a game of dice. Whoever rolls a 6 first wins. A starts the game. What is the probability that A wins? Okay. Let's check this. A and B are playing a game of dice. I hope you know what's a dice, right? If you throw a dice, you get a number either 1, 2, 3, 4, 5 or 6. That's a dice, right? And the question is, whoever is rolling a 6 first wins. Now think about it. Whoever rolls a 6 and A starts the game. So if A starts the game, it is possible that A throws a 6 the first time around and A wins the game. Correct? Or it could be, remember the question is A winning the game. A winning the game in the second round. If A is winning the game in the second round, it means in the first round, A did not win, and obviously B also did not win, because if B had thrown a 6, the game would have ended, right? So A gets a second chance. This could be the second chance. Or, you know what? A wins in the third round. If A is winning in the third round, it means no one wins in the first 2 rounds. Will you agree? No one wins in the first 2 rounds. Because if someone wins in the first 2 rounds, or for that matter, so this is the first round, and similarly, this is the second round. So the not sign, I'm just putting a not over this. The not indicates that no one won, either in the first round or in the second round. Hence, A got a chance for the third round. And this can continue. If you want, you can write one more time. A wins in the fourth round. If A is winning in the fourth round, it means no one wins in the first round, no one wins in the second round, and no one wins in the third round. So first round, neither A nor B throws a 6. Second round, neither A nor B throws a 6. Third round, neither A nor B throws a 6. And hence, A gets the 4th chance and A wins the game. This will continue. There is no end to it. This will continue, right? Now, you need to determine the probability that A wins. Now, I must tell you, in your CAT, anytime you get an infinite series, as an example, the one that you see on your screen, infinite series, there is no ending to it. It got to be an infinite GP, because that's the only series which is there in the syllabus and which is infinite. So immediately think about it as an infinite GP. That's the first clue. But before that, think about it. What is the probability of a person throwing a 6? What is the probability of a person throwing a 6? Can I say probability of a person throwing a 6 is 1 by 6? Remember, a dice has got 6 numbers. So obviously, throwing a 6, the probability is 1 by 6. What is the probability of not throwing a 6? What is the probability of not throwing a 6? Let me put a bar. It has to be the remaining, right? 5 by 6. So 5 out of the 6 numbers are are negative cases, so I will say 5 by 6. Probability of throwing a 6 is 1 by 6, so not throwing a 6 is 5 by 6. Let's get started. So A wins the first round. If A wins in the first round, it means A has thrown a 6 in the first round. So probability of throwing a 6 is 1 by 6. Similarly, here what has happened? A and B did not win in the first round. It means neither of them has thrown a 6 in the first round. Not. So what does it indicate? A not indicates A did not throw a 6. Probability of not throwing a 6 is 5 by 6. Similarly, B not throwing a 6. Probability of not throwing a 6 is 5 by 6. And the third term, A wins, meaning A has thrown a 6. So probability of throwing a 6 is 1 by 6. Yes? Similarly, what has happened in the third term? There are 4 people, 4 turns where no one threw a 6. There were 4 turns, right? No one threw a 6. So can I say basically 5 by 6 into 5 by 6 into 5 by 6 into 5 by 6, right? No one threw a 6. And then you have A throwing a 6. So that is 1 by 6. And this will continue. This will continue. No point writing it so many times, right? So now let's focus on it. Let's solve it. So 1 by 6 plus 5 by 6 whole square into 1 by 6 plus third term 5 by 6 is there 4 times. 5 by 6 to the power 4, 1 by 6 into 1 by 6 plus dot dot dot. This is an infinite GP if you are able to recall and recollect. If you want, you can take 1 by 6 common to make your calculations easy. So 1 by 6 if you take common, 1 plus 5 by 6 whole square. Correct? Plus 5 by 6 to the power 4. 5 by 6 to the power 4 plus dot dot dot. Correct? Correct? I hope you remember what is the formula for an infinite GP. Sum of an infinite GP, can you recollect, is A divided by 1 minus R. What is A? A is the first term. What is R? R is the common ratio. So just substitute the formula here. Just substitute the formula here. So 1 by 6 into the sum of an infinite GP. So the sum is A. A is the first term, 1 divided by 1 minus R. What is R? Common ratio. What is the common ratio? How do you determine the common ratio? Second term divided by the first term. Second term divided by the first term, or the third term divided by the second term, right? It will get you the same answer. So how much you're getting? 5 by 6 whole square. 5 by 6 whole square. Please do the maths. Please do the calculations. 1 by 6, so 6 square, 36 will go up. 36 minus 25 is 11. So answer is 6 by 11. Answer is 6 by 11. 6 by 11. Correct? Brilliant question. 2 concepts involved. Probability and the concept of an infinite GP. I hope you understand. I hope you understand. Let's spend some time how to tick the answer if there were answer options. Now look at the figure. Look at the final answer. The final answer is 6 by 11, right? Would you agree that 6 by 11 is greater than 50%? 50%, because had it been 50%, it would have been 5.5. 11, half of 11, 5.5. Think about it. It is greater than 50%. Why is it greater than 50%? Remember, there are only 2 people playing the game. Only 2 people plays the game, and whoever throws a 6 first wins. Now remember, A has started the game. Because A starts the game, imagine if A throws a 6 the first time, A wins the game. B doesn't even get a chance to play, right? So obviously it would mean if there are 2 players and if someone is starting a game and he can win in the first throw itself, his probability of winning would be more than the other person. It means if there were answer options for this question and if there was only one answer option where the answer was greater than 50%, that would have been your answer. That would have been your answer because A is starting the game, so he has a higher chance of winning. Correct? So answer for the first one is 6 by 11. 6 by 11. Let's look at the second one. Let's look at question number 2. Okay. Number 2. In a garden, 30% of flowers are roses, while the remaining are carnations. 40% of roses and 60% of carnations are red in color, while remaining flowers are yellow in color. What is the probability that a red flower picked at random will be a rose? Now, I have seen students telling me that, sir, this is a question on Bayes theorem. Bayes theorem. Think about it. These are very tough terms that you keep using because you come across them in your books. Do not bother about any Bayes theorem. Use common sense and logic to solve it. Don't use any Bayes theorem, right? We don't even know what's a Bayes theorem. Think about it. 30% of flowers are roses, right? What is the meaning of percentage? Percentage means out of 100. Out of 100. So let's assume let total flowers be 100. Let total flowers be 100, right? Now they say 30% of them are roses, fine. So out of 100, 30 of them are roses. While the remaining are carnatians, fine. Remaining. So out of 100, if you have 30 as roses, the remaining must be 70. 40% of roses and 60% of carnatians are red in color, okay, while the remaining flowers are yellow in color. What is the probability that a red flower picked at random will be a rose? Okay, 40% of the roses are red in color. Fine. If 40% of your roses are red in color, let's write it down. How many of them are red? 40%. How much is 40% of 30? 40% of 30 is 12. Correct? Correct? And how many carnatians are red in color? 60%. 60%. So how many carnatians are red in color? 60% of 70. 60% of 70 is 42. Is 42. Correct? Question is, what is the probability that a red flower picked at random will be a rose? What is the probability? So basically they are saying you have picked up a red flower. You have picked up a red flower, right? A red flower. And what is the probability that this red flower is a rose? Is a rose. So can I say the numerator is basically a red rose? Please try to understand this. Very important. What is the probability that a red flower picked at random? It means you have picked up a red flower. And that red flower needs to be a red rose. What is the probability of this? Very easy. How many red flowers are there? Please add it. 12 plus 42. 12 plus 42 is 54. 12 plus 42 is 54. Out of these, how many are red roses? 12. How many are red roses? 12. Yes? Followed? And you got the answer. That's your answer. 12 by 54. 12 by 54. You can divide it by 6. 2 by 9. 2 by 9. Remember, you don't use a super complicated Bayes theorem. I've seen students using it. I've seen it in the books. Don't use a Bayes theorem. You never need to use a Bayes theorem. You got to do it this way using common sense. This is a Bayes theorem question. But you don't know what's a Bayes theorem. Neither have I taught you what's a Bayes theorem. And I think this is the easiest way of solving the sum. 2 by 9 is your answer. Correct? Let's look at the third one. Let's look at number 3. Let's look at number 3. Okay? Okay, let's look at number 3. A die with 6 faces marked 1 to 6 is biased in such a way that the probability of any face appearing is proportional to the number on that face. If the die is rolled twice, find the probability that it will show 2 sixes. Okay, very important. Probability of any face appearing is proportional to the number on that face. So think about it. What are the numbers available on a die? You have the number 1, you have a number 2, you have a number 3, 4, 5, 6. Right? So what is the probability of 1 appearing? They say the probability of 1 appearing is proportional to the number on the face. Number on the face. So the number on the face is 1. So the probability of 1 appearing, let it be, let's say 1x. 1x. What about 2? You know what? The probability of 2 appearing, or for that matter, any number appearing, is proportional to the number on the face. Proportional. Number on the face is 2, so it must be proportional to 2x. Similarly, one more. Probability of 3 appearing is proportional to the number on the face. Number on the face is 3, so it should be proportional to 3x. And so on. Probability of 4 appearing is 4x, 5 appearing is 5x, and probability of 6 appearing is 6x. Correct? Now think about it. You need to determine the value of x. If you get the value of x, you are done. You are done, right? That's the x you need. Now, how do you get the value of x? you need to frame an equation. Obviously, there is an unknown x for which you need to frame an equation. There is no other data given in the question, no other data. But I think there is one very basic definition of probability which we know. What is probability? The maximum value of probability is 1. Will you agree? The maximum value of probability is 1, or sum of probabilities must be 1. Sum of probabilities must be 1. So obviously, can I say if you add up all of them, the sum of the probabilities is 1. Why 1? Because remember, one of the 6 numbers got to appear. If you throw a dice, you'll have one of the 6 numbers, right? So definitely for sure you can say sum of all these probabilities must be 1, because when you throw a die, one of them is certain to happen, right? So add them, how much you get? 1 plus 2 plus 3 plus 4 plus 5 plus 6 is 21x. 21x is equal to 1, implies x is equal to 1 by 21, right? 1 by 21. And you are almost done. Yes? So let's check this. Let's check this now. Find the probability that will show 2 6s. What is the probability of 2 6s? It means 6 on die 1. You have a 6 on die 1. And then you have another 6 on die 2. That's the probability, right? What is the probability of 6 on die 1? Probability of 6 on die 1 is 6x. Similarly, probability of 6 on die 2. Remember, probability of 6 appearing is 6x. Correct? So how much is? Multiply this. 6 into 6 is 36x square. 36x square. Correct? So please substitute the value of x. 36x value is 1 by 21. So 1 by 21 into 1 by 21. Correct? So please do the calculations. Please do the calculations. 3 12s are, 3 7s are. 3 4s are, 3 7s are. So answer for this is 4 by 49. 4 by 49. Do you follow this? I think it's pretty easy, and it's a wonderful question which has come in a previous year paper. Any doubt in this? Clear? Perfect. Let's look at the next one. Let's look at the next question. Okay, number 4. Let's look at number 4. Okay. Number 4. It's not difficult. It's a pretty easy one. Let's see if you get it. Number 4. A speaks the truth in 60% cases, while B speaks the truth in 80% cases. The probability that they will say the same thing while describing a single event is, okay. So what is the probability of A speaking the truth? Probability of A speaking the truth, okay. Probability of A speaking the truth. Let's write it down nicely. Probability of A speaking the truth is how much? 60%. So 60% can be thought of as 3 by 5. Can be thought of as 3 by 5. Correct? So probability of A speaking the truth is 3 by 5. So in that case, what is the probability of A lying? What is the probability of A lying or speaking false? False. 3 by 5 is the truth probability. So lying must be the remaining. How much is the remaining? 2 by 5. How much is the remaining? 2 by 5, right? So if probability of saying the truth is 3 by 5, probability of lying is 2 by 5. Perfect. Next, let's talk about B. What is the probability of B speaking the truth? 80% cases. So 80 by 100, it means 4 by 5. 4 by 5. Correct? So what about B lying? What about the probability of B lying? You know what? If speaking the truth is 4 by 5, speaking false must be the remaining. How much is the remaining? 1 by 5. I hope you agree on this. I hope you agree and understand. It's pretty simple. Okay. Now let's look at the question. What is the question they're asking? The probability that they will say the same thing while describing a single event. So probability of saying the same thing. What will be the case? What will it be? Probability of saying the same thing. Can I say is the probability of both speaking the truth? Both speaking the truth. Will you agree? In that case, both of them will say the same thing. Or the other scenario, which most of you will forget, is probability that both are lying. Both are lying. Do you agree on this? Do you agree on this? What is the probability of saying the same thing? The probability of saying the same thing is when both of them speak the truth, that's one scenario, or if both of them together lie. Perfect. Let's say both of them speak the truth. What's the case? A speaking the truth is 3 by 5 and B speaking the truth is 4 by 5. Correct? Or both lying. The probability of A lying is 2 by 5 and the probability of B lying is 1 by 5. Please do the calculations. 12 by 25 plus 2 by 25. So how much you get the answer? Your answer is 14 by 25. 14 by 25. Followed? It's an easy one, but I know a lot of you will make the mistake because you ignore the both line case. If you ignore that case, you'll get a wrong answer. You get a wrong answer. Fine? Let's look at number 5. Let's look at number 5. Okay. Number 5. The probability that A does a piece of work is 1 by 3. The probability that A does a piece of work is 1 by 3. So let's write it down. A doing a piece of work is 1 by 3. The probability that B does a piece of work, is 3 by 4. What is the probability that the work gets done? What is the probability that the work gets done? Okay. Before that, by the way, let's put one more thing. If the probability of A doing the work is 1 by 3, can I say the probability of A not doing the work, this is the not sign, is 2 by 3? Correct? Similarly, if the probability of B doing the work is 3 by 4, then the probability of B not doing the work is 1 by 4. Is 1 by 4. Correct? Now think about it. They are saying what is the probability that the work gets done? Probability of work done. Of work getting done. Now think about it. Probability of work getting done is when A and B both does it. Will you agree? When A and B, both of them do it. Or don't forget the other scenarios. A does it and B doesn't do it. And B doesn't do it. Or A doesn't do it and B does it. Remember, you have to take all the three scenarios. When will the work get done? The work will get done if both of them does it or one of them does it. Both of them does it means A and B does it, or one of them does it means A do it, B does not do, or A does not do, B do it. So let's put it, A and B both does it. So 1 by 3 into 3 by 4. Or A does it is 1 by 3 and B doesn't do it. Not done. Not done is 1 by 4. Just substitute the values. Or A doesn't do it is 2 by 3 and B doing it is 3 by 4. So how much you are getting? 3 by 12 plus 1 by 12 plus 6 by 12. So you are getting 10 by 12. So 10 by 12 is 5 by 6. 5 by 6, that's your answer. That's your answer. Correct? Now this is one way of solving it definitely, but I think there is a better way of doing it. Let's look for the other way. Let's look for the other way around. Okay? This is definitely one way of doing it. But in this way, you had multiple cases. You had to add the case 3 times. Think about it. What is the probability of the work getting done? Probability of probability of work done. Probability of work done plus probability of work not done. Work not done. Will it be what? Will it be 1? Yes. Why? Because there are only 2 possibilities. Either you do the work or you don't do the work. So can I say probability of the work getting done is equal to 1 minus the probability of work not done. Work not done. Will you agree? Probability of the work getting done is 1 minus the probability of the work not getting done. When is the work not getting done? The work will not get done only if both of them does not do it. Only one scenario. When will the work not get done? If both of them do not do it. If both of them do not do it, means A does not do it. So 2 by 3 and B doesn't do it. Which is 1 by 4. So how much you are getting? 1 minus 2 by 12. 1 minus 2 by 12 comes out to be 10 by 12. 10 by 12 is 5 by 6. That's your answer. 5 by 6, that's your answer. Followed? You get the same answer. So whether you do with method 1 or whether you do it method 2, you will get the same answer. Correct? It's an easy way. I think the second method is better because there is one calculation. The calculations are very easy. Okay. I hope you understand this. I hope you understand this. A quick announcement now. The announcement is there is a bumper offer going on at the moment. There is a bumper offer running at the moment. What is the bumper offer? Remember, if you subscribe to Unacademy Plus today for 6 months, you just go for a 6-month subscription. We in Unacademy is going to extend your subscription till the CAT. But for that to happen, you need to use the code Parikshit Live, which is there on your screen. So if you use that code, the Parikshit Live, you know what? You get 3 benefits on Unacademy Plus while subscribing to Unacademy Plus. First benefit, you get a 10% discount while subscribing to Unacademy Plus using the code Parikshit Live. Second benefit, you join Unacademy Plus for just 6 months and we in Unacademy are going to extend your subscription for till the CAT. That's benefit 2 using the code Parikshit Live. And the third benefit, this is the only code which will give you free mentorship. I repeat, free mentorship from my side. And mentorship is going beyond your class hours. Remember class, I will obviously every doubt you have will be clarified. But beyond the class hours, if you have any doubts, any queries, any strategies or whatever that you need a mentor. That's what you get if you join using the code Parikshit Live. Yes, so I hope to see many of you in Unacademy Plus because that's where we do the entire course end to end. And remember, also test yourself. It's not sufficient to just keep studying. Test yourself, check out where you stand in the competition today by enrolling for the weekly scholarship test. And if you have doubts, make use of the Ask a Doubt feature on Unacademy. I think that's it for today. Thank you so much. I hope you learned something new. I hope you understood things and I hope you enjoyed the session. If you have enjoyed the session, don't forget to hit the like button. Thank you.